Welcome back to Ugly Truck. Today we're talking LS swaps and what to do with all these wires. So stick around.
When we left off on the last video, I said we were going to start the wiring on it. So that's what we're going to get into today. There's a couple ways of doing it. On this pickup, this is Emily's shop truck. And we did this one the easy way. We had the original fuse box from it. So doing it this way, it was just a matter of connecting 3 wires, I believe, to it. And hooking it up to the battery and making sure all the grounds were there and it fires right up and runs. But most engines don't come with this. So, and this is extremely ugly. We're gonna fix this someday. But when we did this truck, we were in a big hurry. So it only took us maybe 2 or 3 hours to LS swap this baby.
Yep.
Yeah. So you can tell that we were in a little bit of a hurry. Her radiator is zip tied like she's mentioned before.
That's fine.
That's a complaint that I hear about commonly.
You always carry a spare.
Yeah. Yeah, a spare zip ties.
Mm-hmm.
So this isn't the way that it usually gets done. So we're going to show you the way that you end up doing it when you don't have that fuse panel. So let's do it.
Let's do it.
Let's do it. All right, well, if you're going to jump into a wiring project like an LS swap or something like that, I think it's important to know a little bit the basics of a 12-volt system, how everything works. A lot of people don't. There's no shame in that. It seems complicated, but it's really not if you really get into it. So. But I'm going to bore you a little bit. I'm going to just go over a little bit of the 12-volt system that goes on in a regular car, you know. So Emily drew this so you could actually read it and see what each thing is. But this is a battery, okay? Say this is a battery. You got your positive side and you got your negative side on a battery. Well, that battery's got some plates inside of it that they've got half of it's positive charged and the other half of them are negatively charged, okay? Say this battery is capable of putting out 700 amps. So that's its max, okay, that it could do. So all the positive electrons that are on these plates, all those electrons want to do is they want to get to negative. They're going to do everything they can possibly do to get to negative. So if I took a small wire and I went from positive to negative, it's going to do its best to pass 700 amps of power through that. And an amp is just the same as like a garden hose. If you turn a garden hose on and you put your finger over the end of it, the pressure that's behind your finger, making it squirt out the way it does, that's the amperage of it. So if you had 700 amps, for instance, and it was a garden hose, you'd never be able to hold that with your finger. It's going to blast past your finger, no problem. That's what you're doing. So that's where the wire is not going to handle that. It's going to melt. Okay. So any kind of amperage that you're going to introduce to a wire, the wire has got to be able to handle that load. Okay. So if you were going to do that with mechanically, you know, you would have to have something that could really hold on to that pressure that water has got behind it. So that's amperage. It's just pressure, basically. It's not pressure, but that if you think of it like that, that's what it is. And that's also current. If you talk about current, that's what I think of as current. It's current and amperage flowing. Okay. And that's all that a positive battery, or that's all the positive side of a battery is trying to do. It just wants to flow. Okay? So, for instance, a light bulb, okay? It has a filament in it that has resistance. So, only whatever kind of amperage it takes is going to pass through there. So, and then as it passes through that filament, it's going to heat it up and it glows, and then that's your light. Okay. So, but it's still just doing the best that it can to pass through that resistance that's in there and get to ground. Okay. So when you're talking about a current, nothing is done. Okay. Until it actually gets to that. Nothing moves. All right, there has to be a path. It doesn't matter what interrupts that path. You can put a switch in it right there with an open. So a switch is going to be an open circuit, and there's going to be no current flowing until you get that to hit the ground. Okay, because that's all it wants to do. So say for instance a starter. On this pickup, we would have like a number 2 or number 4 gauge wires that go down to the starter. That's because that thing's going to take 200 to 300 amps to start that motor. Okay, the starter solenoid doesn't. It might take 10 to 20 amps, and we're going to get into that. But you would notice that the wires that go down to the starter, they're nice and big wires. So that's why, because they're carrying a giant load. If you ran this wire down to a starter and you went and hit the starter, this wire would burn and melt basically the minute you touched it, because it can't handle that kind of load. So that's how a 12-volt system works. That's all you got to remember, is that just the positive is trying to get to the negative. No matter how it has to get there, that's what it wants to do. All right, so in all this is where relays come in. Okay, a relay. Now, on this video, we're talking about an LS swap. Okay. In 1985, this truck only had one relay in it, or 2 relays. It had a high blower relay and a horn relay. Okay, so those are 2 things that really took a lot of load. A long time ago, back in the 90s, they figured out that they could use relays to fire up some of these high amperage things, and you didn't have to have a giant ignition switch with giant wires going to it. Not a lot of amperage and wires coming into the actual vehicle. So they use a relay as a switch. So this, for instance, we'll say this relay we'll do battery voltage here. Okay, battery plus. All right. So you got battery voltage going to terminal number 30, and this is going to have a nice, say a 12 volt or a 12 gauge wire going to it, okay? Because what this is going to power up is going to be something that's got a pretty good load on it, like the starter solenoid. The starter solenoid takes a pretty good amount of amperage to fire that baby up. So let's say we're going to fire that starter solenoid up. Well, pin number 87 is going to be the one that goes to that. All right. And okay, so we've got a switch here. Okay, so 87 and 30 right now, they're not connected, but in order to make these things connected, you got pin 85 and 86. Okay, and if we put pin 86 to ground, okay, and if we put battery voltage to this, it's gonna send current, okay, through a little, what do you call them?
Contact?
No, a coil, okay? So you're gonna pass 12 volts through a little coil here, and it ends up making 30 and 87 contact each other, okay? So there's your path, and it's going to engage that starter solenoid, okay, and make the starter crank over. The starter's already got a big giant battery cable going to it, so that's how it gets its 200 to 300 amp capable wires going to it, and a giant ground. The engine's a giant ground for it, but that's how a relay works. Rolling. Okay, so we got a for this application, we've got a 2005 Suburban that we took the engine and the computer and all the wiring out of, and we're putting it in an 85 Chevy C10. Okay, so every one of them is going to be different unless you have the exact same instance. But so if we went 2004, 2003, whatever, they're a different engine size, whatever, it's going to be different. Okay, so the thing you got to do is you have to learn how to read a wiring diagram. So for this 2005 Suburban, you need to get a Powertrain management wiring diagram, okay? And this is just the first page, and there's 5 other pages, okay? And we use all data, and on this wiring diagram, all of its fuses are going to be along this top row. So we kind of did an example here, but you go across that top row and you look at every fuse that's coming up, and you have to determine, hey, is this something that I want to power up, and then go along each single one of them and decide, okay, I definitely need this fuse. So and how is it turned on, and so forth. Okay. So I look through each one of them and say, we'll work with this circuit first, okay? I look at it and I go, okay, we got a 20 amp circuit here. It's the PCM fuse. It supplies battery voltage to the PCM all the time, whether your key's on, off, or anything. It's just sitting there, your car, that truck has always got battery voltage going to the PCM. And that's the battery voltage that keeps it alive. It keeps all the memory in it and everything. So those are the 2 orange wires. They're green on our picture here, but in reality, they're really 2 orange wires. And when you turn that C2 connector over, it's literally only 2 orange wires. So, and they go to the same pin. So when I wire it up, it's going to have a 20 amp fuse going to it. So Okay, I got that done. I'm going to move on to my next one. I just knock them off the list. My next one over would be the injector 1 fuse. And that injector 1 fuse, it takes a 15 amp fuse and it fires off 4 of the injectors. It supplies power for them. So it has 4 wires, and then it also supplies power to 4 of the ignition coils. Okay, so it's hot in run and start, where this one's hot at all times. So this hot and run and start, it's going to be turned on by the pink wire that comes out of the 85C10 when you turn the ignition on. It used to go to the HEI ignition, but now we're going to use that pink wire that comes out of the firewall. It used to go to the HEI, but now it's going to go and it's going to turn a relay on. That's going to turn that one on. And it's also going to turn on 6 other circuits, okay? That being 1 circuit, and there's 6 more of them that have to be turned on to make that engine run. So that's how you do it. You start with that one, you look at what it does. You start with this one, look at what it does, and that's what you have to supply power to. So when we get into this here, when you see me wiring something up and you see me wiring relays, that's what I'm doing. I'm wiring up a relay that's going to make this one go, and then if you can see on this one, just in this picture, there's 1, 2, 3, 4 more of them. So 5 circuits right there that are going to be powered up by a relay. And each one of them is going to be powered up by that pink wire that comes out from the firewall. So if you don't use a relay and do it, you're going to have big problems. I don't have the ability to run that many wires to one relay, so I'm going to use a few relays to do it. The powertrain management diagram, that just shows you your circuits that go to your PCM, okay? You're also going to know your power distribution. You're going to have to know that. The power distribution is going to be how power gets to the PCMB and all the other ones that go down the list, how the power gets to that. So most of these, like the PCMB one, goes through a 40 amp fuse right off the battery. And then the injector and all these other circuits have another 40 amp fuse that fires up all of those. And then your starter circuit, which we'll get into, it has its own 40 amp fuse. So you'll have 3 40 amp fuses that'll run all the circuits that go in this wiring system. So the great thing about the internet, aside from watching my YouTube videos aside from watching our YouTube videos, you can get a ton of information off of it. So you'll be able to get a wiring diagram off this. It's also gonna tell you the wire, the pin number. So this one's B8, this one's C10, D10, B9. All of these are going to be pink. This one's orange. The rest of them, almost all the rest of them are pink. But it's in connector number 2, which you can find out is a black connector that goes to it. But if you look at the wiring harness that you get from when it comes with the engine, there's only one wiring harness really that has a bunch of pink and orange wires in it. It's the biggest black connector that there is, and that connector supplies everything that LS engine needs. So but it is connector 2. When you get into wiring up other things, like we're gonna put cruise control on this truck and all the other stuff, then you have to start paying attention to what connector you're looking at. So, but just to make this truck run and drive, there's all your pin numbers, and that's your connector number, and a wiring diagram will show you that. Whatever you're working on, you could be putting an LS engine in anything, but like this one, we're doing a 85 Chevy. So do yourself a favor and buy yourself a wiring diagram for whatever you're working on, and they're cheap. This one was less than 15 bucks, and just by reading one, you'll learn a lot. Sit there and just look it over and trace the wires, and that's how I learned how to read a wiring diagram. Nobody taught me how to do it. I was forced to do it. I had to figure out how to fix something, and I was forced into reading wiring diagrams. And if I can do it, you can certainly do it. Believe me, I taught Emily how to do it. 30 minutes, and I mean, that's an accomplishment, right?
It took a lot longer than 30 minutes.
It was more than 30 minutes?
Yeah, I think we're at like 6 years now. And I still don't get it.
Okay. So get wiring diagrams for whatever you're working on, and study them, and you will figure it out. I promise you. For the most part, all the circuits in a LS swap are going to be like this, where you just supply power to them until you get to the starting circuit, and that's where it gets a little bit more complicated. And we'll get into that too, okay? This computer, a lot of times, it acts as a ground, and that's all it's doing really. All the injectors and the coils on this truck, they have power fed to them, but in order to make it run, this PCM, it just grounds. It's the end of the circuit for it. So that's how it fires off injectors, and that's how it fires off ignition coils. So it does kind of the same thing with a starting circuit too. So you have to understand that the PCM, a lot of times it doesn't put out power to any of these switches. It just supplies a path to ground. Okay, so it's another reason why when you don't aren't 100% sure about what you're working with, I don't start supplying power to anything unless I really studied the wiring diagram and made sure that it's a source to ground, or else it's a source of power. So, sweet. Okay, one of the most complicated circuits in the whole LS swap thing is the starter circuit. When you're going from the starter from like this, we're working with an 85 C10. It's entirely different. On an 85 C10, out of the firewall, a purple wire busts out of the firewall, and that purple wire just shoots off, and it goes directly to the starter. And you can tell I drew this starter, and then Emily drew everything else because the starter looks horrible. So, but that's how they did it. So in 85, purple wire coming out, and it goes bam right to the starter solenoid. Well, in 2005, they don't do that. You don't have a neutral safety switch that's on the steering column anymore that is going to tell the computer that it's in park or neutral. So the way they do it now, they use a relay, to crank the starter over. And the way they do it is you go into your wiring diagram, and you'll find a 10 amp fuse that's it's hot in running crank, and it goes to F9 on the connector, the C2 connector. Okay, so we can find that F9 wire in the C2 connector, and it runs through the wire loom, goes down to the transmission, and passes through the neutral safety switch, or the park reverse neutral drive switch. So this thing, if it's in park or if it's in neutral, this switch will be closed, and it'll supply power to the number 85 pin on the relay. Okay, so, and this is a starter relay, and then so we've got pin 86 that goes to the PCM. All right, you turn your key to the crank position, passes through a fuse, and it sends a 12-volt signal to the powertrain control module. And when the powertrain control module says, okay, well, it's time to crank this baby over, it grounds that system out. So all of this from here, it passes through there, and when it grounds that out, it'll energize the coil that's between pin 85 and 86 on that relay, and 30 and 87 are going to make their connection. Okay, and that's what makes your starter crank over. So it's kind of for what we've been doing so far up to that point, it's kind of a strange circuit, because in order to make this thing happen, it's grounding that out. The other ones, you just don't know that's happening, because say like the fuel injectors and the ignition coils or whatever, it's doing the same thing. All the other circuits that we've done, we're supplying power to them, and the PCM is just grounding it. But when you go to wire the purple wire up out of your firewall, you think, well, that it doesn't make much sense, to do that and go into the PCM. But without this portion of it, it's not going to work, because you've got to have that relay that turns that on. And when you do that, this purple wire that comes out of the original firewall, it is supplying very, very, very low amperage to that truck. So, or I'm sorry, to the computer, to tell it to turn that thing over. And that's why they do that. They don't want, you don't want to have a high amperage load going to your starter. It's a long length of wire, and it's just a better way to do it. Plus, it makes it a lot simpler, really, when it comes to the neutral safety switch. So it saves a bunch of wire, it saves a bunch of amperage on those, the amount of power that has to go into the truck, and then come back out of it. So you don't have an ignition switch that's getting 15 amps drawn off of it, and eventually it'll burn out. If they had done this way back when, in 1985, a person probably never have to replace their ignition switch. It just wouldn't ever had to have that kind of load put on it. So that's why relays are so great. Everything that is taking any kind of a real serious amperage and load is being done by that relay and nothing else. So, but when you go to wire this up, you have to find this that circuit, and without that whole circuit, it's not going to work quite right. So that's the one circuit that stumps people the most on a LS, I think, just because it's kind of complicated. Okay. The other circuit that's kind of difficult Not really. It's more difficult in this one because we got 2 fuel pumps. But the fuel pump relay circuit, that the PCM turns that fuel pump on for a couple seconds when you turn the key into the run position. Okay, so you turn the key into the run position. PCM sees that you're about to start this thing. It fires up the fuel pumps for a couple seconds, but it's also designed so if anything at all happens and that truck's not running, it shuts the fuel supply off to the fuel pump, or the electrical supply off to the fuel pump. So that's the other reason for absolutely using relays and using it the way that the PCM does it, because you don't want to have a fuel pump that runs all the time with your key on. You want to make sure that it's turned on only by the PCM, and if something happens, it shuts off. It's not going to be running. So that's the other circuit that's kind of a problem, but we'll show you that one too. So again, want to step up to the whiteboard?
Sure.
Huh? Oh no, step back, please. Please. Step back.
Step back.
Am I in the frame?
Yes.
All right. So that's why very important to have a wiring diagram for what your engine and transmission, what it came out of, okay, and what it's going into. All right. Every one of them is going to be different. Like this one's got electronic throttle control. We've got one that's coming up that is cable operated, so it doesn't have electronic throttle control. So this whole strip of wiring going to it, it's going to look pretty much the same, but I'm going to get down to a certain point where it's going to have the feed for the throttle control, and there's not going to be a wire there. So that's why it doesn't do me any good to tell you exactly like a follow along type video of how to do it, because it's going to be different. So, and the odds that you're working on an 85 C10 are probably pretty slim. But if you are doing a Chevy, an older Chevy, the one thing, the wires that go to the ignition and the wires that go down to the starter, they were always pink and purple, okay? And then any wire that went into the fuse box that was red, it always had battery voltage. So that was pretty nice. But I don't know, maybe you're putting an LS in a Jaguar or something like that. I don't know. But they all work pretty much the same. So you just have to figure that out and make sure you're doing the right wires. Okay, and use relays.
Yeah.
Relays are your friend.
Yes.
That's what I always say. I only have 2 or 3 friends, but I have 400 or 500 relay friends.
That's so sweet. I'm so happy for you.
I know, and every day my friend list grows as I keep doing this. So tomorrow I'll probably have 405 relay friends.
Yeah.
So makes me feel nice.
Mm-hmm.
Yeah. Mm-hmm. They never call.
Yeah.
But they keep running.
Should have named the dog Relay. It's very helpful.
Oh, you know another great thing that relays are for?
What?
Cooling fans.
Yeah.
And this truck has cooling fans, and so we have to also add some relays for that. So cooling fans take a huge amount of power.
Mm-hmm.
So power's good.
Yeah.
As long as it runs through a relay.
Mm-hmm.
What do you think?
Sure. Okay, so I hope this video helps you guys out in whatever LS swap project you guys are working on. With the right information and an understanding of how these circuits work, I know you guys can figure it out. I believe in you, you can do it. But basically, the bottom line is you need to get Joe Self some wiring diagrams and get Joe Self a fuse box, and you can wire it up Joe Self. But thank you guys for watching. As you can see, we've gotten started on the 85. So stay tuned. We will have a video very shortly coming up on that. We're going to give you guys a good example of how to go about it. But again, you will need the info for your specific engine, transmission, wiring harness, and your specific vehicle. So thank you guys for watching. We really appreciate it, and we will catch you next time.